We're going to look at how to use permutations and combinations, and then after today we'll take a look at how we can use permutations and combinations with our probability. So the first thing that we need to take a look at is the thing called the fundamental counting principle. So when we're looking at the fundamental counting principle, what it's saying, if there are A ways in which event A can occur and B ways in which event B can occur, then the two events can occur in A times B ways. So, for example, if we look at the state of West Virginia has auto license plates that begin with a 4-digit followed by 2 letters and 3 more digits. If no other plates are made for automobiles in the state, how many automobiles could be licensed in West Virginia? Okay. So I like to create blanks to represent what it is. So we've got 4 digits, 2, 3, 4. So with our digits, we have 10 numbers. And so because you have 0 to include, so we have 10 options. It also doesn't say that we can't repeat, so I would have 10 options on each of these. And then we have 2 letters, and there are 26 letters in our alphabet, and then 3 more digits. So because we have that many choices for each of our numbers, and then this many choices for each of our letters, and then this many choices for each of our numbers, we are just going to multiply those things together. So we can do 10 times 10 times 10 times 10, or you could just write times 10 to the 4th, and then 26 times 26 times by 10 times 10 times 10. So you get 6, 7, 6, 1, 2, 3, 4, 5, 6, 7 zeros. Let me recount my zeros. 1, 2, 3, 4, 5, 6, 7. Yeah. So that's how many license plate options that we have available. And then if we want to take a look at the next one, we would do a similar thing. We're going to suppose a planning person at a banquet that cannot decide how to seat the 6 honored guests at the head table. In how many arrangements can they be seated in the 6 chairs on one side of the table? Okay, so we're all on one side of the table, 1, 2, 3, 4, 5, 6, right? So that's how our banquet works, or the table. So we've got 6 slots, okay, and we have 6 people who are going to be there. So in the first slot or spot, 2, 3, 4, 5, 6, we can fit 6 people. But in the second spot, we can't fit 6 people because once somebody's been here, I only have 5 people left to choose from. So this will be 5. And then once these 2 people are chosen, then I only have 4 people left to choose from. So 4, then 3, then 2, then 1. So we do 6 times 5 times 4 times 3 times 2 times 1. Right. So 6 times 5 times 4 times 3 times 2 times 1. So we have 720 ways to seat those 6 people. So then this is how we get this next thing. This is an example of how we have a factorial. Okay, so a factorial is for any positive integer n. N factorial is the same thing as n exclamation point, but we verbally say n factorial even though we write it as n exclamation point. Okay, so when we are taking the factorial of n, it's n times n minus 1, so the number right before that, and then 2 numbers before that, and then all the way down to multiplying by 1. So 6, 1 less than 6 is 5, 1 less than 5 is 4, 1 less than 4 is 3, right? Or you can think 6, 1 less than is 5, 2 less than 6 is 4, 3 less than 6 is 3, 4 less than 6 is 2, 5 less than 6 is 1, and we only go all the way down to 1, so we don't need to do times by 0. And then we have this important fact that you need to know that 0 factorial is the same thing as 1. So we have this button on our calculator because it's really annoying to type 6 times 5 times 4 times 3 times 2 times 1. So you go to math, and then you're going to scroll over to probability. It's faster if you go left to get there rather than going right because it'll get you there faster. And then notice number 4 is probability. not probability, sorry, 4 is the exclamation point. You need to have put your number in before that, so yours will often say answer and then your number, so I need to go and insert my 6 to see 6 factorial. So notice 6 factorial would be the same as 720. Okay? So that's found on your math probability. So if I wanted to do 8 factorial, I would do 8, and then I'd go over, and then you can either hit number 4 or you can hit enter, scroll down to number 4 and hit enter on it. So then we would have 40,320 ways if we had 8 people that we could choose from sitting in 8 spots. Okay? So we have something that's called a permutation. So a permutation is the number of possible distinct, meaning different, arrangements of R objects chosen from a set of N objects, which we can also say N objects taken R at a time. Okay. We have this notation. So there's subscripts on both sides of the letter. So N would be your amount that you are wanting to have, and R is the total amount of, no, I said that backwards. N is the total amount, and R is the amount that you're picking from. So this is your total over how many you're picking. Right? So notice it's created with our factorial. So n factorial over n minus r factorial. Now, the thing about permutations is that our order matters, right? So if we're thinking about that first place versus second place versus third place, that would be when our order matters. If I'm thinking about that we're doing president versus vice president versus secretary, the order of which those people are picked, or the order of which they have vice president, their specific information, their specific roles matters, right? The president versus the vice president is different. Okay? If their order doesn't matter, so if I'm just getting people into groups of 3, I don't care if I call Mary first, John second, and Luke third, as opposed to calling Luke, Mary, and John, okay? Or whatever names I said. Okay? So here, your permutation is where your order matters. Okay? So in how many ways can a president, vice president, and secretary and treasury be selected from an organization of 20 members? So our total amount is the 20, so that's our N, and then we're picking a president, a vice president, a secretary, and the treasury. So that means that our R is 4. So we would write this as 20 permute 4 is how we can verbally say that. Notice both of these are subscripted. And then our formula is going to be n factorial, so the total, so 20 factorial, over, and then you're subtracting your n and your r, so 20 minus 4 factorial. So then this is 20 factorial over, and then 20 minus 4 is 16 factorial. Now there's a way that we can simplify this, because if we think about 20 factorial, it's really 20 times 19 times 18 times 17 times by 16. I'm purposely stopping here because notice on the bottom, I have a 16 factorial, so then these 16 factorials will cancel, so then it's really just 20 times 19 times 18 times 17. So then we get that there's a total possibility of 116,280 ways to pick a president, vice president, secretary, and treasury, because our order matters of president versus vice president versus treasury versus secretary. Okay. Now, there is a permutation button on your calculator, so you need to enter the N number first, so 20, and then you're going to go to math, and then you're going to go over to probability, and then you're going to pick number 2 where it says NPR. So you're going to pick that. Yours will put it in there. Mine, it doesn't put it in there, but you need that number beforehand. So 20 permute, and then we're picking 4. So notice that gives us the same number. So the formula is embedded in the calculator to calculate them. Okay. So if we look at the next one, there are 20 teams competing for first, second, and third place in the disc golf tournament. In how many ways can first, second, and third place be awarded? So here, we want to decide, does the order matter? And in this case, the order does matter, right? Our first versus second versus third makes a difference. Like, people care about if they get first place versus third place. Okay. So because our order matters, we want to do permutations. So we've got a total of 20 teams, so our N is 20, and we're picking first, second, and third. So we're going to do 20 permute 3. Okay. Now, on my calculator, I can do second enter, And then since 20 was our previous one, I can just hit delete and then put 3. So we only have 6,840 ways to pick 3 different options. Okay. If we do our formula, it would be 20 factorial over 20 minus 3 factorial. So 20 times 19 times 18 times 17, and I'm going to stop there because I know that 20 minus 3 is 17, and then my 17 factorials are going to cancel out, so then it's just 20 times 19 times by 18. Notice they give you the same thing. Now, we also have one for when the order doesn't matter. So we call that a combination because we're not caring about what the order is. So again, you still use the n objects taken r at a time, that verbiage. We also have this notation that we can use that's a little bit different. So NCR is the same thing as this notation. So n choose r is another way we verbally can say that. And it's n factorial over r factorial n minus r factorial. Okay? And here, the order does not matter. So this would be like the fact that it doesn't matter how many or what order you put the toppings on a pizza. It just matters that they're on the pizza. Right? So that is also under the calculator. So if we look, Pizza Hut has 19 topping choices, not including the cheeses. How many 3-topping pizzas can be created for the create your own pizza? All right? So in this case, the order doesn't matter. So that means that we're using a combination. So because we're doing a combination, we pick the total amount, so this would be 19 in this case, and then we're picking 3-topping pizzas, so that's our R value. So we're doing 19, choose 3, which I could also write like this. Make sure that you don't put a divide by sign there. It can accidentally be habitual because that's normally what we do with numbers when they're on top of each other. But we don't need it in this case. So this would be the same thing as 19 factorial over 3 factorial times 19 minus 3 factorial. So when we simplify this, our 3 factorial is really 3 times 2 times 1, and then 19 minus 3 gives us 16, so times by 16 factorial. So if I were going to simplify that, I would have 19 times 18 times 17 times 16 factorial, and I'm stopping there because I know the 16 factorial on the bottom will cancel out. Okay? So then our 16 factorial cancels out. I also have that the 3 and the 2 multiply to 6, and 6 goes into 18 3 times. So I could also simplify it like that, and then just put that simplified amount in the calculator. So 19 times by 3 times by 17 gives us 969 over 3 times 2, which is canceled out, so over 1, which just gives us 969. Now on the calculator, you need to put in your number first for your n, so you need 19. And then you're going to go to probability again, so you're going over to that tab, and then in this case you're going to choose NCR, which is number 3. Again, yours will automatically put it on this, crud, I got rid of it. Yours will automatically put it on the subscript. Mine is slightly different on the syntax, so it doesn't do that. So 19, choose 3, which notice gives us the 969. So there are 969 different ways that you can create a 3-topping pizza. This is also how they get, for different marketing, how they can tell you how many different options you have available. You would do things like this to figure out what possibilities you have. So we have 6 men and 8 women have volunteered to serve on a committee. How many different committees can be formed containing 3 men and 3 women? Okay. So of the 3 men, we have a total of 6 men. So we have to do these two. We're kind of combining these 2 skill sets. So the skill set that we had beforehand of the fundamental counting principle, and then our permutations and combinations. So we have 6 men, and we want to pick 3 of them. So in our first slot for men, oops, we have a combination because we're not caring when they get picked, just the order of how they get picked, just that they are picked. So we have 6 men, and we're choosing 3 of the men. And then for our women's spot, we have 8 women, and we're choosing, again, the order doesn't matter, so it's a combination, and we're choosing 3 women. Right? So if we simplify that, we can do our 6 choose 3 and then which is 20, and then our 8 to choose 3. Ugh. I'm not typing well on the calculator. There we go. 56. So then we have 20 ways we can arrange the men and 56 ways we can arrange the women. So then if we want a committee of men and women, we can times all of the options of the committees of men times by each of the committees of women. So we do 20 times 56, which then gives us a total of 1,120 different ways that we can create a committee of 3 men and 3 women with that. Now, just so that you can see, if we have John, Isaac, and Ted, and Mary, Jenny, and Stephanie, right? This is one group. I can keep John, Isaac, and Ted all the same and then switch out for all of my ladies a different set of people. So Elizabeth, Jessica, Sarah, right? And then I can do a different combination of Mary, Jenny, and Sarah, right? So each one of these I could keep John, Isaac, and Ted the same with each of my groups of the women, right? Which is why we have to multiply those two together to get to that value.